For question 3, we have this relative boat motion question. So the question states that each boat begins from rest at point O over here and heads in the direction shown in this diagram here. So boat A is heading in this direction and boat B is heading in this direction. So boat B is actually measured 45 degrees from positive x-axis, and boat A is actually measured 120 degrees from the positive x-axis. It's just 30 degrees plus the right angle over here. Okay, so if boat A has an acceleration of 0.6 meter per second square and boat B has an acceleration of 0.9 meter per second square, I'm trying to determine the speed of boat A relative to boat B until they become 240 meters apart. So how long will this take lah? So first things first, let's find out what do we have. We have acceleration. With these two acceleration, you can find out the relative acceleration. So I just do the relative acceleration. Basically, just plugging the information that I have. So for acceleration at boat A is just 0.6 meter per second square. The direction is 120 degrees from the positive x-axis. Likewise, for the acceleration for boat B is just 0.9 in the direction of 45 degrees. So once I compute the relative acceleration, I'll find that out to be 0.94365 meter per second square. Next, I'll find the relative, angular displacement lah. So I must find the angular displacement of this acceleration vector. This is the same for the velocity vector because they are heading in the same direction. The acceleration vector and velocity vector is the same, as in it's heading in the same direction. So now we know that this is this question, they give us constant acceleration. So with constant acceleration, I can use the kinematics equation of Vf square equals to V initial square plus 2ax. So I'll just plug in the information that I have. So I do not know what's V final, but I know V initial is 0 because it starts from rest. So it's over here, from rest at point O. Plus 2, acceleration is what I've calculated beforehand, and the distance, the relative distance where they are separated is 240. From here I can find out what's the relative velocity, and that will be 21.283 meter per second. So with that, I just plug this into the relative velocity, and the angle that I measured over here or calculated over here is actually this angle. Because I used the tangent inverse of negative y-axis over negative x-axis, so it's actually measuring this angle. So I need to add 180 degree because whatever angle that you write is measured from the positive x-axis. Therefore, it becomes 187 degrees over here. So that's how you do the relative velocity part. Okay. Now next, for question 4, we have this pulley question. So there's a collar A starts from the rest and moves to the left with constant acceleration. Knowing that after 6 seconds, the relative velocity of B with respect to A is 450 mm per second, determine the acceleration of A and B, and the position and velocity of B after 8 seconds. So whenever we see like a pulley question, the first thing that we can do is come up with a constraint equation, because the length of this pulley will never change. Hence, we can make a constraint equation from this. So I set the datum at this pulley over here, so that my reference point is 0. So towards the left will be positive, towards the right will be negative. Okay, towards the left of this reference point would be positive. So from the constraint equation, I can form this equation: 2xa plus xb plus xb minus xa equals to constant. So what does this mean? 2xa is basically this, because I measured that this is xa, so I got 1xa, 2xa, hence here got 2xa. And this length over here is xb, so I plus an xb. This length over here is xb minus xa, that's why I plus xb minus xa equals to c. Now I take the time derivative of everything. So when I time derivative of xa, I get x dot a, and time derivative of xb is x dot b, and then for this it will be the same lah, so there'll be dot xb and minus dot xa. But when you differentiate a constant, you'll go to 0. Then I'll simplify the equation to be 2.xb plus .xa equals to 0, which is the same as 2 velocity of b plus velocity of a equals to 0. Now I'll take the time derivative again, and I'll get 2 acceleration of b plus acceleration a equals to 0. So this is your first equation. So you got 2 unknowns in this equation. So you must find another equation to solve for these 2 unknowns. Next, I know that my velocity, my relative velocity is given over here, which is 450 mm per second. So I put velocity of b with respect to a is vb minus va equals to negative 450 in the I direction. Why is this negative? Because over here, it says that collar A starts from rest and moves towards the left. So when A moves towards the left, it's actually moving in a positive direction, isn't it? However, when viewed from B, B is actually seeing A going to the left. Hence, B relative to A is actually moving to the right. Okay, it's hard to, you try to imagine where instead of the A moving to the left, from a point of view of B, A is moving towards the left of B, hence B is actually moving relative to A is B is moving to the right. Hence when B is moving to the right in relative to A, right, it becomes negative because, as I said, pointing towards the left is positive, and going to the left and going to the right is negative. Hence it's negative 450 mm per second in the I direction. Then I know it's a constant acceleration, hence I can divide it purely by the time, and I can get the constant acceleration of relative acceleration of B from A. So that'll be negative 75 mm per second square. Now I got 2 equations and 2 unknowns. My 2 unknowns are just AB, AA, and over here AB and AA. So 2 equations, 2 unknowns, I can solve for these 2 unknowns. Next, I know that since it's a constant acceleration, kinematics equation can be used. So kinematics equation is Vf equals to Vi plus At. So I take reference to point B, so that's Vf of B equals to Vi of V plus acceleration of B times time. So I sub in whatever I have. The acceleration has been calculated beforehand, which is over here, and the time is given, they said after 8 seconds, so I put 8 seconds here. Vi is 0 because they said that they start from rest. So when collar A starts from rest, that means velocity of A in the beginning is 0. That means velocity of B is also 0 because they are related over here. Therefore, I can very easily solve for my velocity of B, which is negative 200 mm per second in the I direction. Similarly, using kinematics equation, I can find out the displacement or the position of collar B, and that will be negative 800 mm in the I direction. So that's how you solve for question 4.